Good evening. Before introducing tonight's speaker, I want to mention the new system that's in town now. For those of you that would like to have AIA continuing education credit, there is a QR code on the back door, and it will also appear magically at the end of the lecture, not the beginning, at the end on the screen. And if you are an architect, if you go there and say you are not a student, but it will move you to where you can register your number and get credit for this. And the students actually clearly know how the system works with their respect, so I'm not going to go there. So my name is Robert McCarter. I'm the Ruth and Norman Moore Professor here at the School of Architecture, and it gives me great pleasure, which is the reason I apparently was asked, because I'm on a plane to Florence tomorrow at the crack of dawn, but I was asked to introduce the Ruth and Norman Moore Visiting Professor this evening, Javier García-Germán. But I will want to just sort of take a moment to acknowledge the fact that this family, the Moore family, has given not one but two endowed positions to this college, which is terrific. I'm glad to see Carmen here because I know that we have talked many times about this. It's rare that and one is a permanent position, which I hold, and then there's one that allows visitors to come every semester as how we're using it now. So without further ado, because I know he has some very interesting things to show us. Javier García-Germán studied architecture at the ETSAM, which is the school in Madrid. He had a final design thesis honors, Premio Extraordinario Fin de Carrera, 2002, the Oxford School of Architecture, and Harvard University Graduate School of Design with a master in the latter school, a Master in Design Studies 2004, and he was also a Fulbright scholar during that time when he was in the US. He received his PhD in architecture, which was in thermodynamic environments, a critical cartography on energy, architecture, and atmosphere from the ETSAM Madrid in 2014. He is a professor of architecture, architectural design at the Madrid School of Architecture since 2007. He is also the module director of both the master's degree in city and housing, which is at MCH, at the ETH Zurich, and at the UPM, and also in the master's in advanced ecological buildings, which is at the MEB IAAC in Barcelona. In 2004, he founded TAAs, Totem Arquitectos Asociados, an award-winning practice based in Madrid, which explores the connections between climate, architecture, and users. TAAS has recently finished two bioclimatic NZEB buildings. Now, for Americans, I have to translate, that's net zero energy buildings, which of course are a requirement in Europe, or getting very close to it, as opposed to the exotic in the United States. And those two buildings are an office building in Paseo del Castellano 94 and a 159-unit collective housing scheme for Ayuntamiento de Madrid. TAAS's entries for Europan International Competition received awards in the Europan 6, 8, and 10 editions, and TAA's work was exhibited in the 16th Biennale in Venezia in 2018, which was the one that was curated by Grafton Architects. In addition, Javier has authored several articles in international periodicals, Coderns, Balvelt, 2G, etc., and edited and authored several books on energy and architecture, among others, Thermodynamic Interactions and Architectural Exploration into Physiological, Material, and Territorial Atmospheres, which is 2017, from ACTAR, which has received both the Pensamiento y Crítica FAD Award 2018 and the 13th BO Spanish Architecture and Urbanism Biennale Awards. And another book is in Spanish, so pardon me, De la Mecánico alo Termodinámico. This is where I need Monica. 2010 Gili, and Contextos 2008 Hacio un Nuevo Entorno Energético 2008, which is UCJC. Now, he has a very long list of lectures. I would just like to say that he has lectured at numerous institutions in the US, but also China, Mexico, Peru, Argentina, Puerto Rico, and 6 locations in Spain. And just recently, and I don't have any further information, Javier won the competition to be the editor of the next issues of COAM, which is the Colegio in Madrid's magazine, which perhaps he will enlighten us about that. And I want to finish with a couple of things. Aldo van Eyck, when he was teaching here in 1961-62, the Dutch architect who founded Team 10, he wrote a book, his only book actually, and the manuscript for it is in our library, and it was only published in 2008, well after his death. In that book, he talks about the notion of breathing buildings and how modern architecture seems to not understand how buildings need to breathe. And this is Van Eyck. Modern architecture has been trying hard to breathe out without breathing in. But the twin phenomena, individual, collective, part, whole, closed, open, can be understood in their own right in terms of breathing, for you cannot open up unless you enclose. During that same time period that he was here, he designed a building for Jerusalem, a Congress building, and he described it as a space both closed and open, symmetrical and asymmetrical, expanding and contracting, which is a building that breathes in and out. And I think it will be clear why I introduce these ideas when Javier introduces his buildings, because I believe his buildings, among other many characteristics, can be understood as breathing buildings. As Van Eyck says, buildings that breathe both in and out. But in the case of Javier's buildings, I think they breathe air, they breathe light, and they breathe space. I give you Javier García-Germán.
Good evening, everybody. Now everything has been settled. First of all, thank you, Robert, for your generous introduction. It is true that some of the projects I will present are breathing projects, and it was nice to hear comparing me with Aldo van Eyck, who I admire a lot. I would also like to thank you, Monica, you're over there, for your kind invitation to come to WashU this fall term. It is a pleasure to be here in Washington University, to be the Norman and Ruth visiting professor, and of course to share with you, Robert, the sponsor. I'm also very grateful to all the staff, the faculty, and students for your warm welcome. I have to say that I'm enjoying a lot being here. I'm enjoying the very stimulating academic environment. I'm also very happy with my option studio and seminar students. I know you are working hard to find opportunities that climate change is opening to architecture, that are many indeed. Before starting, I would also like to thank my wife Lola, my kids that are over there sitting at the back. I would like to thank them for their enthusiasm to come here to St. Louis, okay? It has been great. And tonight, I would like to share with the whole school some of the thoughts and ideas which are underpinning the work we are developing both in the seminar and the option studio. And for the sake of this, I will be repeating some of the arguments and images you've seen. These ideas also form the backbone of the work we develop in our office. The lecture will have 2 parts. The first part will be theoretical. It will be more or less half of the class. I would like to discuss my architectural agenda. For years, I have pursued to have coherence between the architecture I practice, my teaching, and research. So I think it's necessary to start the lecture discussing this question. This will be followed by a selection of projects. I think we have 5 projects which show my environmental interest and how these have evolved during the last 15 years, more or less. So it's a bit biographical, in fact, from an initial period in which I was interested in environmental questions from a kind of more peripheral point of view, to a second period where I focused in disciplinary questions. I went straight ahead to architecture, and I began studying the relationship between climate and architecture at the beginning from a quantitative point of view with a bit of technical rigor. And lastly, to the third stage, in which I'm right now, where the emphasis is being laid more on the qualitative and the experiential, working on the relationship between climate, inhabitants, and everyday life. And finally, some closing remarks. So let's get on with the first part. As I've said, one of the questions I work with more determination is the construction of an intellectual position, an obsession to know what is the role of the architect and how should the architect work in the contemporary context. This determination has led me first to study and analyze contemporary contexts with its challenges and opportunities, a context in which I'm especially concerned, as you will see, with environment and climate change. Second, to position myself as an architect within this kind of problematic reality. And these reflexive moments finally lead to a proactive moment where this intellectual position is deployed through the practice of architecture. I would like to start showing some of the dead-end paths architecture has followed in the last years. Unfortunately, even though our industry is finally conscious about the negative environmental effects of our actions, I have to say that the approaches our industry is embracing are encouraging and do not lead to a promising future. So the first line is, of course, greenwashing. This banal approach, which applies marketing-oriented strategies to architecture. As we all know, nowadays anything can be declared to be sustainable, from a burger to a holiday package in the Caribbean to the most polluting concrete. A second line of work, which is not very promising either, is energy certifications, from the American LEED to the British BREEAM. It is a business-oriented initiative which offers to real estate practices a commercial solution to environmental concerns. But surprisingly, LEED will not give top marks to a passive building. As you all know, passive buildings do not need any mechanical climate control systems. And if you have no machines, LEED will give you no points in the energy and atmosphere section, which is 1/3 of the possible total score, as the building has no HVAC systems to rate. There's also a third line of work, among many others, which is constituted by ecotech practices. You know that in the light of environmental problems, high-tech firms like the British Norman Foster and Partners to Renzo Piano became ecotech. These firms address environmental problems using sophisticated digital tools, but also very expensive and precise technologies, as is the case of this building, designed by Italian Mario Culcinella in Beijing. However, unfortunately, this architecture cannot be applied to less affluent contexts where environmental problems need to be addressed. I'm not saying that corporate architecture does not need an environmentally based approach, but rather that real environmental problems are in the metropolis of the fast-growing tropical belts, where thousands of passive houses must be built in the next years. And that's where architects really need to focus if something is to be done about climate change. Interestingly, this techno-scientific approach also pervades the academic environment. If we take a look at these books, which have been published in the last decades by designers, professors, and thinkers, which, like myself, have been interested in environmental problems. If you take a look at the words in the titles, thermodynamic, ecology, ecosystem, physiology, metabolism, underline the fact that in academia and across the fields of architecture, landscape architecture, and urban design, a technical and scientific approach has also prevailed. It is true this technical approach has opened up new design opportunities, and we are able to design with more precision. But unfortunately, I have to say that these kind of discourses have unfolded a militant tone, a deterministic and kind of univocal approach, obviating any question which is not related to the performative discourses. I think it is very important to merge these thermodynamic and ecological discourses with a more disciplinary outlook, one which makes rooms for other equally important architectural questions beyond sustainability. And going from sustainability to architecture culture, I would like to bring forward Robert Venturi's Complexity and Contradiction in Architecture. I would like to establish a parallelism between the cultural moment in which this book appeared and the situation I have just defined. Venturi's manifesto championed inclusive, experiential, and material culture to resist the univocal, abstract, reductivist, and white modern movement architecture. This is something which becomes kind of clear when we compare these two houses, the Farnsworth House and the Venturi's mother house, built almost within a decade. Similarly to Venturi, I would like to assert the need for a more inclusive architecture, which complements the rigor unfolded by thermodynamic, digitally driven practices with a stronger emphasis on disciplinary, ordinary, everyday life architectural questions, and of course also with an eye on the human body. After exposing this context, I would like to refer to this diagram, which was drawn by Alejandro Zaera several years ago to define the architectural position of the emerging offices, right? The Zaera mapped a panorama where a young generation of architects look for alternatives to the star system that until then had pervaded architecture. I'm referring to the Gettys, to the Zaha Hadid, etc. You can agree more or less with this diagram, with the positions he is labeling, but I think it seems appropriate to use it as a reference because it is displaying almost all the practices that or all the architectural positions that are embraced nowadays. The diagram is organized into axis of opposite values, okay? You have this horizontal axis that locates populist positions to the left and culturally committed agendas on the right, and a vertical axis which articulates the pole of technique on the top and that of culture below. Among the populists, Zaera situates offices like BIG or the American Rex, which have market-oriented practices. Among the activists, he places both politically committed architects like Urban Think Tank from Venezuela or culturally committed offices like Chilean Smiljan Rakitic. On the other hand, on the vertical axis, he places from architects with a techno-scientific imaginary, such as the Swiss Philippe Ram, to architects that are interested in revising the discipline, like, for example, American Johnston Mark Lee. However, given my interest in environment and climate, where are architects with environmental ideas located? These are found at the top of the diagram, closer to the techno-scientific pole than to the cultural one. This position includes very different offices which share an interest in the environment. From Andrés Jaque, the current dean of Columbia School of Architecture, to other architects interested in datascapes, like the Italian Carlo Ratti, or also architects, these architects from Barcelona with a sensual approach to sustainability. This concentration, I have to say, obeys to this cliché that environmental problems must be solved through science and technology only, which is a question that has already been denounced by thinkers like Ulrich Beck or Bruno Latour, arguing that ecological problems cannot be solved solely through science and technique, for example, adding PV cells to a building, but overlaying technique and culture. However, I would like to argue several questions before getting into the lecture. Can't an environmentally committed architecture overcome its technical focus and engage its cultural dimension? Can an environmentally committed architecture be endowed with historical depth? Can it deal with history, for example? Or thirdly, can an environmentally committed architecture, apart from delivering healthy and comfortable spaces, create an intense environment for its users? Is the quantitative approach of thermodynamic and ecological architecture the only way to commit to the environment? The reality is that those firms that explicitly work on environmental questions are present throughout the diagram, okay? Spanning from the techno-social assemblages of Andrés Jaque to regional historicism architects, from populist market-oriented sustainability of firms like BIG or REX to the social activism of Urban Think Tank, from the climatic parametricism of Akim Menges to the revision of typologies done by TED architects, or even from the position of institutions such as IAC in Barcelona, which is committed to cross-laminated timber, to countercultural positions such as Anna Heringer, recovery of artisan construction techniques. And finally, if we explore also the corporal dimension of architecture, we can find that there is an environmental interest not only in the physiological comfort advocated by Philip Ram, but also in the phenomenological approach of offices like the Indian Studio Mumbai. And at this point, that I think we are more conscious about the plurality of positions within architecture and environmental thinking, I would like to define among these categories my position as an architect. And to do this, I will rely on some of the references we have just seen. To start with my intellectual references, I'm indebted to French thinkers Michel Serres and Bruno Latour, who have shown me that architecture cannot be understood exclusively from a technical or cultural perspective, but as a combination of both. Or authors like Ulrich Beck, and more recently Timothy Morton, who have taught me that architectural objects are not autonomous entities. These questions are at the base of projects such as the new metabolism for a school in Madrid I'm designing, where regardless of the objectual nature of the specific architectural interventions, I'm interested in the set of relationships, climatic, material, biological, social, that the project is mobilizing. Although I share this relational understanding of architecture with the Office of Political Innovation, unlike the singularity, the extravagance, and the optimism of the projects, as is the case of the Cosmo installation at the MoMA PS1 in New York, I have to say that I advocate for an anonymous, simple, and ordinary architecture which is based on generic models and archetypical forms that are easily identified and legible. I think that a house is a house, a window is a window, and a door is a door. On the other hand, as a reaction to the banality of contemporary architecture and the instantaneity of social networks, I also advocate for history, to give cultural depth to our projects. But in the face of regressive positions, I understand that the history of architecture offers opportunities and should be elaborated creatively. As, for example, this competition for a college in Madrid in which historical elements such as a portico and a patio are interpreted to form the spatial, climatic, and social strategy for a building. This interest in generic models and archetypical forms has led me to the idea of typology. That is a kind of old idea. It has become a recurring reference in my work. Beyond the formal interest of the tendenza of Rossi, Crier, and Moneo, or the iconographic turn of Venturi, I'm interested in a renewed idea of typology, which complements its formal dimension with an interest in its performance, not only its climatic performance, but also the experience of the people who live within. And going from the typological to the territorial, I'm not interested in linear and extractive models like this one diagrammed by Howard Odum in the 1970s. I think it's necessary to deploy circular material ecologies committed to the decarbonization and recycling of architecture. However, I think that unlike positions like that of Anna Heringer, who rely on traditional tectonics that can hardly face the challenges of the 21st century, or against the uncritical commitment to cross-laminated wood as if it were a kind of new concrete, I advocate for the recovery of both ancestral and modern building techniques from rammed earth to prefab concrete, as long as they have local material supply, can it be industrially systematized in order to decarbonize architecture. And going from the metabolic scale to tectonics, opposing any excess of design, I advocate for sober and austere tectonics, which champion the use and reuse of raw, durable, and recyclable industrial materials, as is the case of this facade for a building in Madrid we will see later, built with prefab concrete and with dry assemblage to ensure its recyclability. I also advocate for an aesthetic of collage and assembly that overlays generic construction systems, such as concrete block masonry, with systems ordered from the catalog, like these louvers you can see in the photograph, integrating vernacular technologies with industrial systems, massive low-tech systems with more sophisticated components, so that the performance of traditional buildings is updated to meet contemporary comfort standards. I'm not only interested in the design and construction of buildings, but also in its occupation and enjoyment. This is something Lefebvre proposed as early as 1974, claiming the need to overlay kind of mathematical space with the practical and sensory dimension of social space, overlaying the kind of more technical side of architecture with its occupancy. And from this perspective, I have to say that I'm interested in combining the medical and the physiological questions linked to comfort with psychological and sensory questions, introducing a more hedonistic understanding that is linked to emotions and to enjoyment. And in connection to this question, I'm also interested to approach architecture from the perspective of everyday life. Situations like this one, which can be found in modern and contemporary documentary photography, show a successful interaction between climate, the built environment, and daily life. I'm interested in situations where well-being and pleasure is achieved through design, and we can find multiple examples in ordinary and vernacular architecture, like this beach bar, or chiringuito, as we call it in Spain, where we can learn how architecture, well-being, and everyday life are pretty tied together. This interest in everyday life makes necessary to complement these books with a literature with focuses on environmental questions from the perspective of well-being and pleasure. I have to say that it's now clear for me that championing a design approach with a strong disciplinary and technical base is not opposed to close attention to users' everyday lives, so that architecture, climate, and habitation go hand in hand. To finish part one and begin with the projects, I would like to briefly return to Zaira's diagram where, after explaining my interest, I can now map with precision my position. Renouncing both to activism and historicism, I'm interested in a revisionist attitude towards architecture with an inclination for materiality and experience. On the other hand, renouncing to populist positions, I'm interested in a technocritical and cosmopolitan attitude with an inclination for the human body and its metabolism. In the face of globalization and its tendency to make everything homogeneous, and as a reaction to regionalism that is kind of exploding the universal, I say I would like to think I advocate for what I call a generic specific, a position that is capable of articulating cosmopolitan dynamics with local contingencies, the universal with the singular. Okay, let's go to part two. I will show several projects. I will try to show with these 5 projects how my position's architectural agenda has evolved in the last years. All of them are competitions. Some of them were successful, and we managed to build the projects. There's also a house I built several years ago. The selection might be better or worse, but I think it's the most pedagogical because I will try to show the evolution of interests I have pointed out in part 1. These are kind of the 3 phases that I would like to address. I will show first kindergarten school, which was designed applying environmental ideas in an open and explorative way. Then I will show, as part 2, an office building in which I focused on architecture and climate, and did this with a lot of technical precision and using digital tools. And finally, I will show 2 projects, the house and a social housing scheme that Robert mentioned, in which, without abandoning this kind of quantitative precision, I complemented with a more qualitative, introducing everyday life and all these concepts I mentioned at the very beginning. So this was the first commission we got in our office back in 2005. The building, it's a kind of very small kindergarten, about 600 square meters. The building was made up of two elements. It has a continuous floor that I consider is the closest surface to a child, right? I designed with a lot of precision and with care this floor, which unfolded between the inside and the outside. And it also had this technical roof, which provided all the elements that the floor needed. Provided light, water, and energy, activating them for the use of the children, for the learning environment. The interior space was paved with sports flooring, kind of soft tiling, which was heated with radiant floors. You can also see in this picture how this roof provided the light to the interior spaces, generating this kind of interaction, common spaces between the rooms, the classrooms. It provided this soft and continuous warm environment where kids could crawl. From the inside to the outside, the exterior floors included, around the building, a first ring of sandpits where the kids could play, and next, Jardin en Mouvement, inspired in the work of French gardener Gilles Clement, kind of gardening movement, which changed with the seasons, right, openly, freely, and where children could learn the passage of the seasons. These floors, both interior and exterior, were activated from the roof, where the rainwater was collected to irrigate the garden, where the solar radiation was also accumulated to heat up the interior floor. On top of those skylights, we placed thermal panels, which heated up the water that went to the radiant system under the pavement. As you can imagine, this project corresponds to this first stage in which I explored environmental questions, but not knowing quite well how to put them together. The building had the ambition to interact with the sun, with the rain, with the surrounding landscape, and it harnessed these elements to activate the children's learning environment. In these beginnings, I think that climate was explored, adding more or less technological devices, like the thermal panels in the skylights, but it is not a part of the spatial and material conceptualization of the school. This will only be approached in subsequent projects, and I will try to show you the changes. The building was wrapped in in a net supporting an ivy creeper, and now covers the entire kindergarten, mediating between the building and the surrounding garden. I would like to move on to the next project. This is an office building in Madrid, located in one of the principal avenues of the city. We were very lucky to be able to participate in this competition. It was a restricted competition in which most of the well-known consolidated offices in Madrid participated, and we were able to win it. Although its construction has been completed recently, it resulted from a design competition we won back in 2012. This project was developed with a lot of precision, okay? And I will try to show you how it was achieved. Almost all the elements in the building were under climate. We knew the climatic effect of all the elements that were introduced into the project. Of course, this project is connected to my doctoral dissertation I was preparing at that time, and also to the Akhtar book, Thermodynamic Interactions. The project starts from these facts, crude facts. In Madrid, any office building is a dissipative typology. And this means that it is continuously generating heat. I mean, Madrid does not have a climate as cold as San Luis has. And if you analyze its energy consumption, An office building in Madrid requires air conditioning throughout the year, except for the coolest winter months, when it needs a bit of heating. This implied that architectural strategies should go at least in two directions. On the one hand, the building should go down to capture the cool underground, the cool temperatures that are lying under the site. And on the other hand, the building should provide a solar shield. One of the requisites of the developers was to have a glass building, okay? So we needed to have a really good protective shield for the sun. For the first strategy, very radical steps were taken. Ducts were embedded in the 2-meter thick foundation slab the building has, almost 20 meters below the ground, and in the 40-meter deep diaphragm retention walls around the parking, which together with 15 geothermal wells, which run 300 meters deep, capture the underground cool temperature below the site. These low temperatures are then pumped back to the building, to the slabs, where a radiant system embedded in the concrete slabs cools down the users inside the building. The result is a commercial office building without false ceilings. Flexibility is provided by a raised floor. In this building, the structural and climatic dimensions are integrated into, I would say, a convergent strategy that is conflating kind of the structure and climatic questions. The corrugation of the slab you see in the picture aims to maximize the radiant heat exchanges between the building and its users. It is important to point out that the building energy saving strategy takes on board how the body works. You know that the body is a heat machine that is exchanging almost 50% of the heat it gives off through radiation. It, however, exchanges only 25% through convection, which is the heat transfer mode air conditioning uses. Cooling with radiant slabs, compared to the typical air conditioning system used in office buildings, results in incredible energy savings, since the human body is much more efficient at exchanging heat through radiation than by convection. So looking at the human body, we managed to reduce substantially their energy budget to the point of not having any air conditioning. And Madrid in summertime can be really hot. The second strategy was to design an effective solar protection shield. First, this has to do with the building's massing. Urban regulations imposed a step volume for the office. It's the step volume you can see under the glass envelope. This volume, wrapped with a faceted skin, increased the capacity of the building envelope, and we managed, through the shape of the envelope, to reduce the impinging solar radiation by about 10%. So through the geometry of the envelope, we managed to tackle again energy questions, addressing energy problems through architecture. The geometry was also complemented by a material strategy. This faceted skin was built in a reflective glass, which through the arrangement of the different pieces and the thermodynamic properties of each of the glass tiles, we protected the building from the sun in a very effective way. This material strategy was designed with parametric precision, since the position and the performance of each of the pieces of glass was placed in the building was controlled through a complex grasshopper script. And this tool, apart from providing precise quantitative data on solar protection or the energy we were saving, enabled us to interact with its boundary conditions, mediating between many parameters that were in the site. From the solar questions to the wind, to the shadow casted by surrounding buildings. Since building solutions required to systematize to ease fabrication and assembly processes, we designed 8 different modules with particular technical and aesthetic properties, and the parametric model was very useful to arrange these 8 modules, indicating the most convenient position across the envelope. So we had some modules that were more permeable to enable natural ventilation, other modules that had more reflective qualities, which were positioned in the west facade, etc. It enabled to select particular types of glasses too, and the kind of glasses with the thermodynamic properties more indicated for each position. We had 4 different kinds of glasses. And also to decide the best angle in which the glass tiles were to be placed. This same logic was applied throughout the envelope, wrapping the whole building with the same skin. Apart from this kind of energy-saving architectural process, we were also interested in the aesthetic dimension. And we looked at artists like Olafur Eliasson or the French Arnaud Lapierre. We thought that this glass skin also required a perceptual dimension. Faced with the solid materiality of the brick and stone buildings in Madrid, we thought that installations like this one seemed appropriate, dematerializing the physicality of the building, diluting its presence amidst the reflections of a cloudy sky. We thought it was a kind of interesting strategy. Madrid is well known for the beauty of its skies. We intuited that the materiality offered by this installation would be appropriate to reflect the dynamic chromatism of Madrid's changing skies, proposing a more sensorial approach that we found could somehow balance the overly technical approach we had unfolded for the rest of the building. The skin reflects the Madrid skies in a variety of ways, depending not only on the time of the day, from sunrise to dusk, but also on the meteorology, on cloud arrangement, cloud density. The reflective skin captures the sky of Madrid, diluting it in hundreds of flashes and reflections, which are introduced to pedestrians walking along the streets. At the scale of the whole building, this faceted prism, I think, is also amplifying this effect, forming a great kaleidoscope which dematerializes the building, reflecting the beauty of the changing skies. And I think that in doing so, it's also intensifying its experience and making them a shared public sensorial experience, which I think is one of the attributes of the project. Some more pictures of the entry hall, this kind of double space. Some pictures of the interior. Of course, it's a Carabanchel building. It's now fully occupied, but these are the finishes with which we delivered the building. And finally, the top floor public terrace. Okay, let's go to the last 2 projects, which shift this quantitative approach I have shown you in the office building to a qualitative and experiential one. These 2 projects are related to the study of climatic types I have been developing in the last years. This has run in parallel to other research endeavors, principally an exploration on Spanish climatic typologies, which has been financed by the central government to find in vernacular and ordinary Spanish architecture an alternative to the more quantitatively driven energy regulations. The first project is a single-family summer house in El Escorial, which is a town close to Madrid in the mountains. Unlike the previous project, which started with crude thermodynamic facts, this one began its design with a documentalist approach, which explored a variety of questions which range from the site's climatic conditions to the local material culture, to a set of historical references I thought were appropriate for the commission, the experience and lifestyles of the inhabitants too. Numerous climatic types were studied, among which I would like to highlight this American wooden house with this green roof, which is included in the Sybil Moholy-Nagy's book, Native Genius in Anonymous Architecture, and which my WashU students know quite well. And an interesting Russian wooden cabin, the izba, which combines the insulation of wood to the outside, as the American log cabin, with the thermal mass of that huge stone fireplace in the inside. This massive fireplace is lit in the early morning, and as the day progresses, stores heat throughout the day to progressively release it along the night to warm the inhabitants of the cabin who sleep on top of the fireplace. The project starts by designing a typical room. It is kind of the elemental, spatial, and climatic unit of the house. And it has the capacity to articulate the main objectives of the project. It has a big window to enjoy views. The project is located in a beautiful forest. In addition, each room has an opposite window to enable cross-ventilation to cool down its interior in summertime. Like the Russian izba, the interior of the room has both thermal inertia, as it is built in exposed concrete, and it can cool down, so that it can cool down in summer and in winter. And externally, it has been insulated with projected cork and clad in wood to add an extra layer of insulation. The project is understood as a set of rooms which is spread across the forest, searching for the best conditions. Numerous configurations were tested with help of Grasshopper again, looking for an spatial organization which traded off between the views, the best solar orientation, and we were also interested in the wind that goes uphill in the night, okay? The room arrangement in the bottom left corner, this one over here, was chosen as it met most of the design requirements. The rooms are located on the upper floor with views to the forest and to the historical monastery of El Escorial. The orientation of the rooms enable both solar collection in winter and night cooling ventilation in summer, catching these nocturnal winds that blow up the hill. On the ground floor, the shared spaces are connected to the garden, so the typical room is transformed to open to outdoor space. In sections, the rooms are raised to look over the lower floor, generating a shaded porch that is connected to the garden. The interior of the house was designed to meet the wishes and also the beliefs and the ways of life of the owners, ensuring that the architectural and environmental conditions were well articulated. The interior finishes were defined according to their climatic performance. For example, terrazzo tiles were located close to the fireplace and to the south-oriented bay window for heat storage, whilst wood was used in the rest of the room. And from this post-occupancy drawing, full circle, we go to the interior of the house, testing that the collection of rooms mediate between interior and exterior, between outdoor climate and indoor atmosphere to provide a well-calibrated environment. On the ground floor, the domesticity and coziness of the upper rooms dissolves to open interior space and integrate indoors with the garden. The house is located in this beautiful forest with these fantastic views. Know how the rooms rise following the slope of the mountain to maximize views and to create this shaded outdoor space. The house, similarly to Moholy-Nagy's log cabin, is covered with a green roof that has over the years grown with plants, providing this extra insulation. Cork and wood are giving to the elevations, but also integrating the house into the woods and the surrounding environment. Okay, so we are getting closer to the end, and to finish, I would like to explain the last project, public housing scheme we have recently completed in Madrid, being a much larger project than the El Escorial house. However, it has been designed with same design protocols. It is a conventional building with simple, straightforward, ordinary architecture. It is built with prefab concrete panels, which gives it a roughness and dryness that is typical of social housing buildings. The durability of the building underpins the selection of these concrete panels as the principal building material. These panels have this built-in fascia that is kind of marking each of the floors, but by flying slightly over the facade, as I learned from the Smithson's Economist building in London, prevents water runoff, addressing the weathering and maintenance of the building. These panels, which are up to 8.5 meters long, ease a lot the construction process, enabling a fast assembly line. In addition, the panels have been bolted to the slabs, which will facilitate future disassembly procedures. Its stark and utilitarian aesthetics hides a network of interior public spaces which are passively tempered, being warmed up by the sun in winter and cooled down by summer winds, catching a smooth breeze that blows in Madrid in the early morning from the northeast from 6 a.m. to 9 a.m., and that has the capacity to make Madrid a city without air conditioning, which is something amazing. This solution is achieved through a design process which, unlike the office building, combines technical and cultural drivers. First of all, we look for everyday life situations which are climatically and socially successful. This image shows a typical situation in Madrid, going out for night cooling, or as we commonly say, salir a tomar la fresca. We look for situations which evidence successful climatic, urban, and architectural interactions. We also look for references in historical and contemporary architecture, like this traditional house in El Cairo, studied by Hassan Fati, or the Austrian pavilion at the Milano Expo in Turin. With these examples, we try to search for the architectural strategies which will provide the success of these situations. We draw detailed qualitative studies of the interaction between inhabitants, climate, and architecture, delineating heat sources, heat sinks, energy and air invisible flows, to have a kind of very clear idea of how architecture is interacting with climatic questions. And we also try to understand the connection between the human body, physiological needs, and architecture, trying to explore the potential of particular spatial and material arrangements to achieve those situations. During the design phase, we carry out, of course, rigorous climatic digital simulations. These ones have been undertaken by Atmos Lab, which is a climatic consultancy firm located in London, which are necessary to verify that the design climatic situations work correctly. The project also started with a typological approach, similarly to the one I used in the previous project. We began designing a typical housing unit. It has a room-based layout without corridors and with two differential elements. First, an entry hall, which has been oversized, adding the built area of the corridors, and has become an extra room, which is that one is located over there. And a generous terrace, which is 1.8 meters wide, which is an outdoor room, and which, similarly to the hall, provides an outdoor connection to all the rooms in the unit. Following the Lacaton basalt greenhouses, I much admire This outdoor space can be closed in winter with a transparent membrane to warm up the apartment. Note in this drawing that the wall between the terrace and the interior has no thermal insulation, so that the stored heat can be driven indoors. In summer, removing the membrane, the terrace becomes an outdoor shaded space, which works as a kind of climatic threshold, very similar to those ones typical of the Mediterranean architecture. Once the housing unit was defined, we moved on to design the external form, the massing of the building. And we tried many different configurations until we found the one which best performed both in summer and in winter time, which is the one here. I mean, we tried many different urban typologies, from the most conventional blocks, like the ones you see on the right, to more particular arrangements. The developer required to have double-loaded corridor to reduce the building costs, which generated a really compact building, but that had the problem that it didn't have any natural ventilation. The final scheme is organized in these two zigzagging three-story blocks, which form the base that articulate these three outdoor patios and which connect the building to the urban context. Over this base are located 4 8-story towers, which were placed with care not to obstruct the solar radiation that was coming into outdoor spaces. To compensate its capacity, the building has been designed to catch these cool breezes I referred at the beginning. For this purpose, a network of wind catchers capture the cool nocturnal northeast winds and conduct it through the interior network of public spaces to cool down the interior of the building. The indoor material palette is formed by this kind of high thermal inertia materials, such as exposed concrete block or terrazzo tiles, which have the ability to store heat effectively. The placement of the wind catchers was not arbitrary. The aerodynamic behavior of the building was simulated until the right location was found for each of the wind catchers. The final arrangement guaranteed a minimum amount of pressure throughout the interior corridors, being able, despite the fact that, as I mentioned, the building is quite wide, it's a double-loaded corridor, to naturally ventilate each of the housing units. That's why it was so important to locate correctly the wind catchers, the number of wind catchers and the location of the wind catchers, so that we could have the right amount of pressure inside the corridors. The building has this kind of ordinary windows and terraces. They are inspired in the typical openings of the Madrid 19th and early 20th century Ensanche buildings. Its verticality enables a more effective control of the climate, of incoming solar radiation, providing at the same time a more direct visual connection between the interior and the exterior, promoting social interaction. The regularity of the facades masquerades the wind catchers. In this image, for example, the balcony and the window over here on top of the door are hiding 2 wind catchers, forming this kind of external patios. These patios make the buildings more porous, introducing the ventilation and light to internal corridors. And going back to the layout, we can see the path that the cooler takes, entering the building from the northeast side through those openings, going through the corridors, cooling the interior public spaces until it reaches the leeward outputs, where the air comes out again to the exterior. In this network of interior public spaces, the 4 social condensers the building has are the real protagonists. They play an important role in the ventilation patterns. They manage to induce a pleasant atmosphere, which makes them instrumental spaces in the social life of the building. In addition, they are located in the intersection of corridors, elevators, and staircase wells, assuring the vitality and its social performance. Each of the 159 housing units comply with European Union energy regulations. Despite the fact the building layout enables its natural ventilation, they are mechanically tempered to comply with the demanding European regulations. However, this network of public spaces is passively tempered. When outdoor temperatures drop below 21 degrees Celsius, the wind catchers and social condensers louvers open automatically, letting the breeze enter the building to cool down the walls and floors. The high thermal inertia of the concrete, masonry, and the terrazzo floor tiles, combined with the airflow, which is controlled by these louvers, guarantees that the space is cooled down in summer. These hanging plants also contribute through evapotranspiration to make the dry Madrid climate more pleasant. These plants are also equipped with water nozzles, which contribute to cool down further the space through evaporation. With this combination of traditional and industrial building systems, architecture, climate, and daily life, I would say, go hand in hand, delivering these pleasant atmospheres that are at the base of the lively and vital communal life that the building has. And to finish the lecture, I would like to make a very brief concluding remark. Over the last years, we have worked to avoid that the debate on sustainability ends up becoming a technical discussion on energy savings, but rather an architectural form of knowledge, mediating between technique and culture and taking on board disciplinary tools, but also the lessons from history. I think that we need, as architects, to design environmentally sensible buildings which engage in architectural debates. It's very important for me to engage architectural debates, provide not only healthier and more comfortable environments, but also an intense and stimulating atmosphere for their inhabitants. Thank you. Thank you. Okay. Okay, I don't know if there are any questions before you leave.
Sure, I'll go ahead now.
Do you want the micro?
I'll just be loud. Yeah, as architects, we're charged with predicting the future. That's a really difficult thing. And what I mean by that is, when we're designing, we're trying to predict how the buildings will perform. Right? And we have technology that allows us to understand it more clearly. And I appreciate all your graphics that help to explain things that are otherwise invisible, right? and invisible to many of the inhabitants. These graphics are extremely helpful in explaining to us. And so you're using the technology that helps you to predict. Do you have kind of feedback, yet because a lot of these projects are still fairly new, into how it's performing compared to how you were predicting?
We have not been lucky as to be able to monitor any of the buildings we have designed. We are currently applying for money to do this in this last building, and I hope to be able to know if things are working as we predicted, right? It is also problematic because you know that simulations are not always correct, right? And digital tools for the time being are helping a lot, but it is true that they have many flaws and many problems, right? And what I found after years working with different softwares is that the most important thing is to, as an architect, have a clear idea of how heat is moving, the very basic physical processes that are occurring. And that can be done without the aid of digital tools, okay? So I think that this qualitative approach is very important because it makes designers conscious about the things that are happening and need to be kind of connected to the digital processes that to times are run by people that don't understand how things are working, so that you can detect if there are any problems. But it is true that until, if buildings are not monitored, it is very difficult nowadays to know if things are working or not. It is true.
How is it determined in social housing and in hill house, which of the models or layouts would be most efficient? Were there tests or simulations that were done?
As I said, we worked with an office that is based in London that is used to, they are experts in testing how things work, right? So we work with a different variety of softwares. In the case of this building, we didn't use Grasshopper, okay? So that meant that we tested different configurations of wind catchers. The wind catcher is basically half of a house, right? So we had the capacity in the layout to propose different positions, okay? We had different alternatives with different numbers of wind catchers and different positions, and the people from London tested them to see what was the pressure, the wind pressure that was being generated within the corridors, okay? So it was, I would say, not a purely digital process as the one we undertook in the office building, okay, in which the glass configuration came out automatically from the computer, okay. It was a kind of more analogical process, but we generated 10 different possibilities. And with the 10 simulation, we could test that the pressure in the corridors was enough as to naturally ventilate the houses, okay? So when we reached that point, we thought that the climatic process had finished, okay? And we concentrated on the purely domestic and building questions, okay? There was a question over there.
Thank you, Javier. It's a wonderful lecture, and glad that many of the students got to see it. Two quick questions relative to this very, in terms of the units themselves, because the developer required the double-loaded corridor. Am I clear that it's really the public spaces and the corridors that involve the cross ventilation, but the units don't have any kind of ventilation that works off of the corridor? Is that correct?
The corridors and the public network has been designed to enable natural ventilation in the units.
In the units as well?
Yeah.
Just because I know the graphics have been connected to the public spaces, so it's interesting to see how that works as well, unless I missed it. But
Yeah, I can show a drawing to explain this question. This hallway, right, has a double door, okay? And one part is a window and the other one is a door, so it can be opened, okay? And the pressure builds in the corridor with a specific wind speed so as to be able to ventilate. It is true that not all the units can be ventilated. Of course, the ones in the towers have two facades, so they ventilate pretty well. And the ones in the slab, we reach, I think, around 90% of natural ventilation, and we have a 10% that could not be ventilated. It was very difficult to attain. Anyhow, the developer locked those windows, okay? Because, they are a public developer, and they have to comply with energy regulations. So, we designed it this way, and we knew this was going to happen, but we thought it was necessary to provide it. Maybe in the future, energy regulations change and switch to a more passive mode, and the building will have the potential to ventilate naturally the houses, okay?
I was wondering if you could talk a little bit more about the Venn diagram of architectural positions from the very beginning. I thought it was interesting the different opposites that were pointed out, such as activist versus populist, and technique versus culture. And then, of course, like the array of other ones that were brought up later, such as technocritical and yeah, I was curious about those and was wondering if you could describe a little bit more about what those positions were.
Yeah. Esta se queda buena. Okay. This is a kind of very complex diagram. And I think it is very successful because it manages to define many of the positions that exist nowadays in architecture culture, right? My interpretation tries to simplify, right? And I'm kind of defining those parameters that are helping me to define my position. So it is kind of, maybe it's not a kind of pure interpretation, okay? But what is, I really find that these two axes, the horizontal one, debating between populist positions, right? Those ones that are maybe closer to commercial drivers, or even to user-friendly positions. And this one, the technical versus the cultural, are very clear, right? And in this diagram, you have at the bottom, for example, all the architects that are dealing with disciplinary questions and that are dealing with history and with the culture of architecture, okay? And the ones at the top are dealing more with a technical position, right? So it's the two opposites that architecture is continuously dealing with. Am I more technological, more technical, or I am more interested in history, right? For me, this axis is the most important also because, as I mentioned, most environmental thinkers are criticizing the fact that our society is kind of addressing sustainability through technological means. And what is now kind of pretty clear is that it has to be done with a combination of both, okay? I mean, it makes no sense to have very energy efficient cars if there's not a kind of awareness of the driver that you should consume less. So it has to do with technique, but also with culture and with everyday lives. So that's why I think for me, in the context of this class, this kind of opposite poles are the most important, okay?
I feel like vernacular technologies, like for example, would that be considered a cultural, I guess, intervention or technological?
I think it's low tech, right? So I think it has a interesting combination of technology and, well, it's a culturally developed technology, right? Piecemeal. So it is kind of articulating well both poles, okay? Any more questions? I don't think that Madrid or Spain is a good example, right? You know that sustainability problems are global problems, And if we cannot address the building demands of developing countries, or those parts of the world that are fast growing and which don't have economies that can finance green architecture, right? We are kind of doomed. So I really think that we need to, my interest in low technologies and in cultural solutions has to do with the need to be able to implement environmentally aware architecture throughout the planet, right? I'm really interested to know how a low energy passive house can be built, I don't know, in Dhaka, right? Those are the places where the real problems are, and in universities like this one, where we have the capacity to develop solutions that can be applied throughout the world. So I really think that it is very important to develop that kind of simple knowledge that is embedded in passive buildings to be able to address construction as a global problem, okay? I know this answers your question.
In Spain, in the residential context, please, those metal shutters that fly outside the window are very popular, and they're pretty effective at shooting out solar radiant heat. Did you incorporate any of those in your designs, or do you like to sort of embrace the outside instead of shutting it out, or how do you use those in any way?
I think it is very important to be able to control solar radiation. I think those kind of blinds are very interesting. It is true that it is not the only way to control solar radiation, right? For example, the window, through the shape of the window, you can deal in interesting ways also with solar radiation, even though the fact that blinds are necessary and are complementary to the shape of how openings are designed, okay?
Specifically referring to the facade screen of the office building. When designing a system with parametric design that it can take all these like data inputs and output a functional but also beautiful screen, how do you go about like defining the visual system that can take in that data, produce something functional but also beautiful?
Yeah. I explained that we designed 8 kinds of panels, okay? So each of those panels had a location of sheets of glass that had different kind of climatic peculiarities. Some of them are more porous, others are more reflective. Each of those 8 pieces was, of course, modeled with physical models and with real glasses to check which patterns were appealing, okay? So, I mean, in the protocols, with the protocols with which we were working, the aesthetic dimension was being considered, okay? And it is true that the final arrangement was somehow mechanical. It came out of the grasshopper, okay? But it had been previously thought out so that the arrangement was pleasing to the eye, okay? Maybe last question? Monica, or? No, go ahead.
So, you mentioned culture, which I think is a very important thing when we're discussing architecture, of course, because architecture is a manifestation of culture. And a lot of your work is, obviously, it's addressing climate change and very inventive, and especially for me, what I like about it is how low tech it is. But whenever we talk about, like, say, construction culture in, say, the United States, where it's not being driven a lot
Yeah, I think it's a very difficult challenge because the building industry has its own protocols. And I have to say that building systems are increasingly more complex and multi-layered as time passes, right? And I think this is indeed very problematic. I mean, in my lecture, my projects have been focused on the climatic dimension, but there's also the metabolic dimension that is also very important, and that is dealing with where do materials come from, what's the material sourcing, what are the material logistics, etc., right? And what is clear is that buildings are what is called monstrous hybrids. Do you know what's a monstrous hybrid? Yeah. A car is a monstrous hybrid, right? That you cannot disassemble and separate and recycle because it has so many different pieces that it's impossible to do. And buildings really are very similar to cars. I mean, not as bad as cars, but the amount of layers and the way in which materials are put together makes it very difficult to be able to separate them and recycle them or reuse them, right? I think that we need to advocate for an architecture that is simpler, right? And nowadays, many architects are working with monomaterials, right? I mean, it's maybe you have to go for a wider or a wall, but it is true that if it's a brick wall or if it's a stone wall or if it's I don't know, rammed earth wall, you know exactly where materials have come from. You know exactly the climatic performance because it is very easy to simulate one single material. And it is also very easy to disassemble and recycle materials, right? We are not only going for monolithic, but also for raw materials, right? I mean, the less intermediate industrial steps, the better, because that means that if you are using a raw material, when the life cycle of the building finishes, you still have a raw material to use in another building. So I think that it is difficult to face the building industry, but with a bit of cunning, you can determine several material strategies that might help at least to know where things are coming from and to ease how materials will be transformed and used in future buildings, right? Thank you very much.